I'm Leire, and along with my colleague Enrico, we want to share with you one of the challenges that we faced when implementing tenanted streaming with Flink in Workday, because it has a few of the special requirements on the encryption. On the encryption side. Yeah, that's the abstract.
Yeah, agenda.
Cool. It's kind of hard to see. So this is the agenda. We're going to introduce a little bit Workday and what we do, what do we need Flink for, what are those special requirements we were talking about that made us like a bit of a headache to implement Flink. Then we're going to see like the approaches, the solutions, summary, and we're going to finish by talking also about a couple of other challenges that we saw separate from the one of this talk, in case any of you have experienced that, and perhaps that gives an option for talks and discussions. Cool, so what is Workday? For those who don't know, Workday, it's a company that provides financial, human capital, planning services to some of the biggest companies in the world. Here on the corner that I'm just covering, you can see some of the customers that we have and a few of numbers. In the next slide, I'm going to talk about a couple of numbers. This one, 40 million, over 40 million workers and over 100 billion transactions, which is quite a large number. And I just wanted to emphasize that in this conference, there's been a few talks on other use cases for perhaps retail or other type of information in this way. Workday is a system of records, so it has all the information from all its users, all like data from their profiles, pay slips, transactions. So it's quite a complex system to work with its data. The big number of the 90% customer satisfaction that I'm sure you know is a hard number to get, that we're quite happy about. And this little bit that we've been nominated for Future Fortune. And enough about Workday, let's talk a little bit more about Flink. So why does Workday need Flink? To give you a bit of context, Workday bases its success, or it's like a monolithic service that has all the information that I was talking about earlier. At the start, when Workday started, it was all good, it's all there, all the information is accessible from the system, but with its growth and with the newer features or innovation, that there was a requirement of perhaps extracting some of that data to be able to use it elsewhere. An example for this is machine learning, which is the department that we work on. It is quite expensive to apply algorithms for machine learning within a proprietary system, so within Workday, which forced us to get that information out somehow to apply then to aggregate and to apply, to give it to the data scientists to apply their models and algorithms too. And well, Flink was the winner option to provide that, because we all know it's a good tool, it's very fast to correlate and aggregate all that data for us to use elsewhere. And in terms of the actual infrastructure that we have in Workday, we have a bit of a different case than the usual ones that we've been looking around here. We use OpenStack, and that was a choice that was a little bit imposed by the company because it has a proprietary OpenStack platform that we had to use. We are also implementing it for Kubernetes at the moment, but we are not ready yet. It's in the process. And there we have a job per cluster. The fact that we have OpenStack forced us to create some deployment and orchestrating tools. Also, because of this proprietary platform, everything is not available to us to work with. We have some specific APIs, which was a little bit like harder to work with and work around it, but there it is. And then, well, it just plugs into the usual login, usual metrics, monitoring, all that stuff that Workday has. And we are also quite keen to providing libraries because we work in platform, so we provide stuff for other developers to build more Flink jobs. So we're trying to make it standardized and as easy for them to develop as possible. In terms of the jobs themselves, currently we have 6 different jobs in production across 6 different data centers, and they process almost 1 billion, well, it's like hundreds of millions of messages per week across all jobs. The nature of these jobs, most of them are data pipelines, so they just, as I explained at the very start, we have the monolith, so it's mostly take this data, transfer it, and put it somewhere else, mostly S3 and HDFS for offline and online model training. The second type we have is anomaly detection, which is used for fraud. And the third one is generic inference services. So this means that we're just gonna get that data and do some inference on it using some offline models. Like, for example, is the for bookkeeping for financial transaction, which means if there is a transaction that is missing or corrupted or something, just to identify those. And all that said, I'm going to leave it to Enrico to explain why we had to scratch our heads a little bit more than usual for this.
Yeah, so given the requirements from Workday as an enterprise cloud solution provider, we have very special very special requirements in terms of architecture, in terms of how we deploy our software, and those requirements have had created some issues with deploying scalable and production-ready infrastructure on Flink. And we can see here 2 main requirements that created the problem. So, as I mentioned, Workday is a technology provider, enterprise software technology provider that serves thousands of tenants. Tenant in enterprise software is a representation of a customer, so one of these big companies. And software as a service in the cloud normally works with multi-tenancy architecture, where you can see that multiple tenants are grouped together to be served from the same software layer. These requirements, with the second requirements that I'm going to show here about security, are a sort of contradicting in Flink. Why? So the security requirement says that at any point we cannot encrypt or store 2 pieces of data coming from 2 different tenants on the same file system or same transmission. What does it mean in practical? That I cannot simply encrypt a storage and put 2 pieces of information coming from 2 different tenants on that storage. This is going to break our security agreement with the customer. So we had to work out these requirements to be able to bring to production a Flink infrastructure for our customers. So what does it mean in practical? So if we start from a very generic Flink overview, this is a common graph where we have multiple services that produces data, send it on a bus, we use Kafka, we have some Flink job that does some computation and send some result back to Kafka or to storage. This is all good, it's all right from one customer, one tenant. And this transparently result in a series of serialization, and the serialization of the data you can see here, exchange of data between task managers, spilling or storing data on disk for checkpointing or for safe pointing, storing safe pointing on external file system and retrieving to recover. Those are all moments, parts of the infrastructure where Flink will serialize and deserialize the data transparently from the job developer. And this is all done. We are using in our infrastructure AVRO to define always the type structure, and AVRO is going to be used by the platform transparently. So here it's all good. But if we see again this picture with a multi-tenancy concept, we can see that on the producer side there are the same services also for a second tenant. And you can see that the rest of the picture didn't change because of our multi-tenancy architecture. So we have always the same stack of technologies from Kafka and Flink and the storage that serves multiple tenants. So what does it mean to the serialization layer? You can see those are all red points where problem can occur, where we are going to break our contract with our customers because we are going to store data encrypted by the same key. For example, here there will be a TLS connection, so we are going to use only TLS encryption. Or we're going to here with local file system where we have local encryption. Again, we have only just one key to encrypt the data coming from multiple tenants, and so on. So those are all problems that we had to solve if we want to bring this technology in production to serve our customer. Now, Leire will go through the solution overview and we'll go a bit more in detail on how we solve it.
So you've heard Enrico saying like our problem here is that we need to encrypt this data at all times pretty much. So the first approach was to wrap the data with a container that will contain that encryption logic. And this is a bit of a representation, so that wrapper will contain the tenant information and then some getter or setter that will have that how do we want to interact with those to encrypt the actual message. The problem with this is it works very well at source and at destination, but it doesn't work well in between. And we all know that one of the key points on streaming is that we need to be able to access this information for filtering or keying or anything like that. But in here it wasn't just enough because, for example, if we have this user data object and the Flink job wants to use it in a state, and then that gets checkpointed, that will not be encrypted because at checkpoint in time, there is no access from that job on this particular information. So then the solution ended up being to handle encryption at serialization. This means that we need to implement some way that every time this gets serialized or deserialized, it will be encrypted or decrypted transparently. For that, we had two options. One was extending the Flink library, and another one was extending the AVRO library. Eventually, AVRO was the winner because extending a library means putting some custom code that then every time there is an upgrade, one has to port along until it gets perhaps acquired by the actual library itself. And in this case, Flink moves really fast, so AVRO was a bit of a peace of mind option to not have to be trying to keep up with the upgrades, porting all these changes. Here's a bit what I just explained, more on a diagram. So what we're trying to achieve with this is object comes in, serialized by the standard functionality of AVRO, and then we want this hook to kick in to do our custom bit. And similarly on the decryption, we want our custom logic to kick in to decrypt it, to continue with deserialization, and then the message can follow on. For this particular bit, we had to consider three main parts. One of them is the serialization library itself. So we need a way for this library to, upon receival of message, to delegate that encryption or decryption logic to the object, which is the one that knows what tenant it belongs to, what way I want the encryption done, and so on. Then there is the common library. This is the one that has the encryption logic itself. And finally, we need a process to mark a message as I need to be encrypted. I am tenanted, I am sensitive information. And I'm saying this because we've been talking about multi-tenancy all along, but not every single message that we transfer needs to be encrypted because there are messages that don't belong to a particular tenant. They are, say, metrics of the system or other generic information, and they wouldn't have this logic applied to it. It's only for the ones that belong to a particular tenant. And this said, we have here a bit the same, but in a more visual way. With the three parts. So message comes in, AVRO serialization is doing its serialization, but delegates the encryption logic to the object itself, to the POJO. That one has the tenant information and the encryption logic. It will trigger a get the key from the tenant. The key will come back, encrypts it, and then it will return it back to the serialization library. Now that we've seen the overall view, we're going to dig into the actual 3 parts that I said, more the implementation. So first is the serialization library. And in here, we had to extend the library to create an interface that will allow us to delegate that logic. So in here, we can see this is the interface that the object will have to implement for being considered encryptable or needed encryption. After serialization, let's remember that first the serialization logic from AVRO kicks in, and then the delegate, so it's after serialization, and likewise, before the serialization, it needs to decrypt it and then hand it back. And lastly, on this part, we're going to see the 2 pieces, the writer and the reader. The highlighted part is what we added on the AVRO library. So it's quite simple. It just sees if the message received is of that particular interface. If that is it, then it literally just delegates it back so that it does whatever logic we want to put in there. And similarly, on the writer, it will first check it, delegate it back to do whatever is needed before deserialization, and then it will continue with the AVRO standard logic. And now Enrico is going to continue.
Yeah, so we have seen how we extended the AVRO library to enable this concept of delegating after the serialization and before the serialization. The code change in the AVRO library is very tiny. We are going to open a PR to the Apache AVRO project soon, and it can be used for many things. It just delegates after an action is done and before the deserialization is done to the object or to the class that is implemented by the object that is going to be serialized and deserialized. Opening this hook, we call it hook, to delegate this phase of the serialization, we then implemented on our side an implementation of this interface, where you can see here that after the serialization, we receive the information from AVRO that is already serialized. We extract the tenant from the object, so information about the key, the tenant that will provide the key. And then using our security library, we do the encryption, passing the binary set that we want to encrypt and the tenant that will be used in the library to reach out to this service, get the key and encrypt the data. And then we send it back to AVRO to proceed sending to the network layer or to the file system layer. Same on the other side. If a message is received, we have seen in the code in AVRO, and is going to be deserialized to a class that implements our serialized with tenant encryption, we will receive here the decoder. From the decoder, we'll extract first the tenant. With the tenant, we can reach out to the service to retrieve the key, decrypt the bytes, send it back to AVRO that will do the rest of the work, deserializing it to the object. Final of the 3 parts that we have described before, so to repeat, was the hook in the AVRO libraries, logic to do the encryption and decryption, was a way to mark classes to be tenanted. How we did that, so we have a pipeline that converts AVSC files, so AVRO description file, to POJOs. We have this pipeline that runs a Gradle job that uses a plugin to convert and create these POJOs. And we modified a little bit the template we've seen a minute why. And those POJOs are then included as a dependency in your Flink job. And that means that every time Flink will have to serialize or deserialize these libraries, everything will be hidden from the developer and will be encrypted and decrypted. So no need to change anything in the job development. Why did we change the template? Because we want to, as I mentioned before, we want to mark which classes are tenanted. So we just change it, and any class, any POJO that is generated out of this template will have this extended serialized with tenant encryption. That is our implementation of the delegation interface. And we had a second change to allow this specific case. So often data are multi-layer structure, And here you can see an user data. This is an object that has an address as another object. Now there is a common pattern, a common thing that is done in Flink is going to be maybe to extract the address and use it in a state, or use it in a map, or use it as a stream by itself. We need the possibility, we need to enforce that this object, again, is going to be encrypted by the tenant that generated the whole data. So whenever, this is a bit complex, is how are written the default AVRO templates to create POJOs. So every time that we create a get method and we extract a piece of information that is, again, of a type serialized with tenant encryption, we will pass the context, that in our case is the tenant, down to this object. And so again, the infrastructure will always be able to encrypt this piece of data with the right tenant key. This is also, here we are showing a relatively simple example, but this is gonna be used also in our infrastructure to follow GDPR requirements, because in this way, in a Flink streaming infrastructure, we are always able to pass and to maintain the context of who generated this piece of data. That is very difficult in a streaming environment, because data are mixed, data are used as a state, they are used in maps, and so you're gonna lose information. So as a summary, we just review what we have done. So what are the normal flow for us to develop? We start from a schema. We use our pipeline to generate POJO classes that are marked with tenant encryption. And then you can see that data are produced. And the moment that the serialization is required, AVRO serializes the information, sees that the class that is implemented in this object is of this type of serialized with tenant encryption, so delegates to that class that has the information about the tenant that created it, the encryption. Via a shared encryption logic, we do the encryption, we retrieve the keys, we receive the key, we encrypt the data, we send it back, and it goes to the network layer. Opposite, from the network layer, we receive the file, we receive the message, it's a binary. We recognize in AVRO that we are trying to deserialize to a class that implements tenanted data. So again, we delegate to this class the decryption. The class will retrieve first the tenant, get the key, receive the key, decrypt the data, send back a byte that at this point is not encrypted anymore, and AVRO can go ahead with the normal deserialization. This allows, again, to be completely abstract, and we can go to sleep with a peace of mind that no developer forgot to encrypt some data, and we are going to have any security issue in our infrastructure. To close, I wanted to just mention a couple of other challenges that are I think nice for the Flink for the discussion of Flink, and we are also open to rediscuss it after the presentation. Here they are the biggest problem that we had to bring our infrastructure in production, starting from OpenStack. OpenStack was a very prominent solution to virtualize services in data centers, especially in private data centers. The problem of using this technology is that it's not so widely used anymore, and now also in internal data center we are moving more toward Kubernetes. So we had to write a lot of code, and specifically in our case, again, we are talking about enterprise quality software. So security breaches are no-go. So we are really have really high standard of quality and standard of interacting with the operational and production data. So we have no way to interact with our infrastructure in production. So that means that there is never a communication outside from operational layer to infrastructure, unless we are on a machine owned by operational support. Those operational support multiple services. They cannot handle all the possible bits and tricks of Flink. So we needed to abstract and create some processes that can be used by them. So For example, we had to create tooling so they can kick off and the creation of a complete cluster or a recycle of a complete cluster with complexity that you can see, for example, here. When a job has a save point of 120 gigabytes, it may take half an hour to take a save point. How can we create a tool that automatically run the creation of save point, draining of the job, stopping of the job, starting of a new cluster, and restarting from save point? Everything has to be in a job completely that can be called in one single line by an operator that has no clue of Flink. So the complexity here has been really high, has been a really big burden on us to really deploy an easy operable infrastructure. Another problem has been S3 writing. So the data distribution that we have, as I said, we have some data that comes from from thousands of tenants, and we need to store it in thousands of folders multiplied by the number of types. So we divide in S3 by folders, by type, and by tenant. This we have seen some issues between the Hadoop and the S3 libraries. And this is still on discussion. We are in open discussion with some guys in Ververica, and we are going to open a discussion on the Flink community. We may have a solution, but if you have seen something like that, please reach out to us or check for news on the Flink community. Another problem is end-to-end test. We have very complex production data. As I said, we don't serve a lot of very simple data, but little very complex data records. And it's very difficult to recreate a very production-like data distribution, especially with encryption logic. When we need to have an end-to-end data, when we had to stand up thousands of services to provide keys, it's going to be very expensive. So it's very expensive also in time to really create all this logic to do it automatically. Another last problem, challenge, let's say, that we use the parameter tool. So the parameter tool is the suggested way in Flink to read parameters from the job manager and then pass it to operators. Our system, OpenStack, distributed some parameter directly on the machine, on the file system. So we extend the parameter tool to just read this information from file system, add it to the parameter tool, and then it can be distributed to operators. The problem comes that some information are per machine. For example, the key used to authenticate it to another service to retrieve the keys for a tenant are distributed by machine. So some information are loaded from this local file system, but gonna change from machine to machine. So we had to create a two-step parameter tool where we initialize it on the job manager, receive the CLI parameter, receive the initialization parameter from the JVM, receive the local file system parameter that normally are generic. We use this parameter to set up the job, set up parallelism and any kind of information. Then we pass it to operators, and operators lazily, in the first moment that is loaded, will also load local file system parameter and override any kind of information that needs to be changed for local processing. Again, this we are going to post some information on the community, but if you have questions, we are here for answering. And I think we have 10 minutes more. Here there are our emails. Here there is our office dog. And feel free to reach out to us or question now.
Do you need to worry about key rotation at all?
Yeah.
So how do you do that?
So our security team provides us libraries that does key rotation. So what you have seen here in the presentation is a very simple implementation of what we do. our data context contains much more information, so we don't keep only the tenant in the serialized with tenant, but we keep also multiple type of keys. So we use different keys for transferring, for storage, because state can be long-term, and then for transferring again, we have multiple keys at different phase. And the one that you're talking about, the rotation, can be a problem for storage. So the rotation is handled directly by the library. So we have a versioning system of keys, so we are able to reread and rewrite data based on different versioning, and we maintain different versioning. The problem is key re-encryption. So by some requirements from some of our clients, data stored for longer than 15 days has to be also re-encrypted. Well, above 3 weeks, I think, needs to be also re-encrypted. So that means that we need to retake all this data and re-encrypt it on the fly. This is technically possible. We have a paper, an internal paper on how to do it, but it's really computational heavy. So the idea is to broadcast a signal into the Flink infrastructure that will be reaching all the operator, that will pick up this signal and request a re-encryption of all the state. So we will swap we will deserialize and reserialize with the new keys. So it's a force of encryption. We don't implement it at the moment because we keep, for machine learning, at the moment we are good to keep data for 15 days because GDPR compliance, because it's much easier to keep light models, and we don't have so longer term models unless it's with non-tenanted data. So we are working toward that, but we don't have it in production at the moment.
Okay, thank you.
Hi. Do you do like aggregations between customers, analytics on that, or could you simplify this by separating into separate Flink jobs for each customer?
Single Flink job per customer means that we need to always maintain thousands of jobs running in production, so technically it's not really possible. Well, technically it is possible, manageable, I don't think so. Separation of tenant, at the moment in Flink, we don't do aggregation of customer tenants. So it's a completely different world of security on how we agree with our customer. We have some agreements of some specific data can be commingled between customers to do projection, but it's a very new topic. But in general, we don't. And we keep it separate, and we need to one single cluster for all of them, for each job, let's say.
So this is pretty unusual to have encryption in transit. So what was the particular motivation why customers demanded that?
Well, our customers are pretty. They set a really high bar, let's say. I mean, we are a system of record of workers. You have seen 40 million workers of really top level companies that will not accept any security failure, let's say. And from banks to big corporation, that their standard to hand you over the data is really high. So you cannot miss on these steps. So these requirements of never co-encrypting data is one of these requirements. To accept contracts, we cannot pass on this.
Even on this, it is a requirement that they accept an extra agreement to even transfer the data, never mind transfer it encrypted.
Yeah.
I have some kind of similar question like you. So, I mean, so you used AWS because you are using S3. So I would suggest maybe. So have you considered simply to have a different account for a tenant on AWS, and so that they are splitted? I mean, you said that you will have some kind of quite many different jobs, and you need to monitor them. But this is some kind of you need to do in some way.
Yeah, I mean. Definitely, we can separate on the AWS side. I mean, we work with AWS. We use doesn't come to mind the encryption level that we have on AWS per tenant. But the problem is that Flink itself, the infrastructure, will commingle data on your file system. There is no way to prevent it. States grows over the space that you have on the heap, windowing, or just simple checkpointing. If you put a tenanted piece of data in a checkpoint, in a state, automatically will be serialized on the file system by the infrastructure or on a Savepoint machine. So there is no way to prevent that in Flink itself, there are going to be commingling of information, unless you create a cluster for each customer. That is, I mean, then all our business is gonna be collapsed by cost and by operational work. Yeah. This is why the software as a service common pattern of multi-tenancy infrastructure architecture.
Then let's thank the speakers.
Thank you.